Good day, ladies and gents. We're on day 18 of the EOC review. This is on circles. We're talking about central and inscribed angles, exterior angles, tangents, arc length, and sector. So we got a lot of stuff we're going to be covering in the next 6 questions. All right, so let's zoom in a little bit. All right, in the circles shown below, the measures of arc, PR. So arc means the curve, right? So arc, PR is 120. So here is P, here's R. So we're talking the arc, so that's 120. And the angle, so this is angle this time. So this is angle RPQ. So RPQ, so the angle's at P, because that's the center letter. So RPQ, so that would be this angle right here. That right there is 40. So that's the angle. Okay, what is the arc of PQ? So we want the arc. So here's P, here's Q. So we are looking for this right here. All right, so there's a couple of different ways how to do this. So I will do both ways in just a little bit. So I'll just redraw this just so you can see what's going on in my head. And I will show you both ways on how to do this same problem. So this was 40 right here. And our goal is to find this. All right, so let's do the first way. So one way how to do this, so option 1 is, now we are trying to get the arc, right? So we want all arcs. So this is we have this arc. Can you find this arc? So this is 40 degrees. If you project this out, then this arc right here would be 80 degrees. And then on top of that, we know that all the way around in a circle is 360. So 360, if we subtract the 120 and we subtract the 80, what would we be left with? So just so you can see what's going on in my head, zoom out a little bit. All right, we have 360, subtract the 120 and the 80, we'd be left with 160. So this right here is 160. So that's one way how to do this. So if you have any angles, create arcs and see what we get. A second way how to do this, so we know that this is 40, right, is go ahead and find the angles, right? So if this is 120, if I go back inside, so 120 projected this angle. So if this is 120, the inscribed angle makes 60. I know that all three angles of a triangle make 180. I'll zoom in a little bit here. So I know all that makes 180. So 180, if I subtract the 40 and I subtract the 60, I'd be left with 80 degrees right here. So this is 80. Now I could project this out. So if this is 80, this would project 160. So those were two different ways of how this find the same answer. So 160. So this was the answer. So two different ways on how to find the same answer here. Awesome, and that's number 1. Let's keep going. Number 2. For number 2, we have given that circle O below, what is the measure of arc? So we're looking for the curve, the arc of ADB. So ADB. So that's this big one. Ooh, tricky buggers. So we want to find that. And then later on, they said, hey, if the radius is this, what is the arc length? So they're asking us two different things here. So this projects out to be 85. And we know that all the way around in a circle is 360. So if I take 360 and I subtract that 85, I'd be left with 275. So 275. But that's not the only thing we have to do. We also have to find the arc length. Arc length is equal to the percentage of the circumference. So that is angle over 360 d pi. So what is the angle that we're talking about? We're talking about 275 over 360. Now, if the radius was 2, the diameter would be 4, so that'd be times 4 pi. All right, so let's put this all in the calculator. So if we put this over 1, we'd multiply straight across, right? So 275 divided by 360 times 4 times 3.14. Here's the problem. They did not say anything about rounding. They didn't say anything about rounding. So something's up. So what we could have done is just multiply straight across. 275 times 4. So we get 1100 pi. And then over here is still 360. And if I simplify that, so if you simplify that, 1100, I know I can take out a 5, and 360 I can take out a 5. Okay, I can take out another 2 out of both of those, so 220 divided by 2 and 72 divided by 2. Oh, I can take out another 2, so 110 divided by 2 and 36 divided by 2. There we go, that's as far as I can go. So I would get 55 pi over 360. All I did was simplify. Or I could do 55 times 3, or I could just go back to what I had before. So 275 divided by 360 times 4 times 3.14. So both answers, 1, 2, 3, 4, 5. So technically both answers are correct. Just be aware of what they're looking for. They didn't say anything about rounding, so I would go 5 decimal places. But let's just say that I just made a typo, and let's just go 9.6, just for the heck of it. So this was a typo. Round to the nearest tenth. Okay, so there was a typo on that one, round to nearest tenth, and that would be 9.6. And that's the answer, number 2. All right, number 3. Kayla inscribed a kite. So that means all the corners are on the circle. That's what inscribed means. If the measure of arc, so we're talking about the arc right here. So arc, ADC. ADC. So all of this from here to here is 205. What is the measure of angle ADC? So they want to find this right here. That is our goal. So once again, there are multiple ways how to do this. So I will do this 2 different ways, just so you can see what's going on in my head. So this is X. We definitely have this right here is 205. All right, so here is one way how to do this. One way is we can find this other arc right here. So 360, subtract the 205, and we get 155 is this right here. And now if I divide by 2, I would get this right here. So divide that by 2, and you pop out with 77.5. And that was our answer. Okay, a second way how to do this is if this is 205, then I can find this angle right here. So 205 divided by 2, this angle right here would be 102.5. In addition to that, we know that these two right here, they make 180 degrees. So if those two right there make 180 degrees, so 180 minus the 102.5, and look at that, I'd be left with 77.5. So those are 2 different ways how to find this. Zoom in just a little more here. And the answer was 77.5. And that's the answer, number 3. Okay, number 4. All right, so number 4, they want us to find angle B. So they want us to find this. So let's call that X. Now, what we really care about is what projected that. So here we go. This projected this arc. So I'll make that red. And it projected this arc. I'll make that blue. So now, is the angle on the inside, outside, the center, or on the edge? So this is outside. Because it's outside, we're sad. We're super sad. So that means what we're going to do is the angle equals the arc minus the arc all over 2. So arc A and arc B. All right, so here we go. So what was the angle? The angle was x equals the big arc, that blue one. Ooh, wait, I don't know what that is yet, do I? I gotta go find that. So all the way around in a circle is 360, correct? So if I take 360 and I subtract the 65 and the 125. So I put that in the calculator. So 360 minus 65 and the 125, and I'd be left with 170. So this right here is 170. So I'm going to take this big arc, 170, minus the little arc, which is 65, and divide by 2. So 170 minus 65 equals, then divide by 2, and I would get this number. Now be careful. A lot of people do this. 170 minus 65 divided by 2, and this is wrong. Yes, no. So this one is wrong, okay? Because what it did was it only divided the 65. I need to divide the whole thing. So this one's wrong. This is correct. So 52.5 is the answer. So we get 52.5. Awesome. And that right there is the answer to number 4. All right. Fabulous. Number 5. AB and BC are tangents. AC respectively. Arc AC is 130. So here's A, here's C, that is 130. So that's this right here. All this is 130. They want to find angle ABC. So they want to find the angle right here. All right, so on this one, it's the same thing as what we did before. These lines create this arc and this arc. So I need to have the red and I need to have the blue. So the red is 130, but the blue, I don't know what the blue is. But the good thing is I know that all the way around a circle is 360. So all I have to do is take 360, subtract that red one, and I'd be left with the blue. So if I put that in my calculator, 360 minus 130, I would pop out with 230. So this right here is 230. All right, so now is the angle on the inside, outside, all that stuff. So it's on the outside, right? So if we're on the outside, we're sad. We're super sad. So we're going to take the angle, and that's going to equal the arc A minus arc B all over 2. All right, so that'd be the angle, X, equals 230 minus 130 all over 2. And I ran out of room, so I'll put it down here. So X equals, so 230 minus 130, I get 100 all over 2, which equals 50. Okay, so we got that answer right there is 50. Bounce this out a little more. So 50 is our final answer. Awesome. And we are on the last one. Oh, so excited. All right. Okay, so number 6. The area of the sector of a central angle of 130 with 38 inches squared. All right, so the area of the sector with this thing. So the area of the sector is this. That's what that is. The area is this. And it also has the central angle. Determine the length of the diameter. Okay, so there's a couple different ways how to do this. One way is the actual algebraic way. So we know that sector is equal to the percentage of the area. So the sector equals the angle over 360 pi r squared, right? We know that the sector is actually this. So 38 is equal to the angle, which is 30, over 360 pi r squared. So I'm just showing you one way how to do this. This right here is actually a number. So I'm going to change that to a number. So if I put this in my calculator, so 30 divided by 360 times 3.14. I get this number, right? Okay, so I get 38 equals 0.261 1, 2, 3, 4, 5, and I can go 7, r squared. Okay, so this turned into this, right? And what would you do next? We would divide, right? So 38 equals this big number. We're going to divide both sides by that. All right, so let's put that in the calculator. So 38 divided by 0.261667. And we get this. 145.2227449 is equal to r squared. And now what would you do next? We would square root both sides. So the square root of 145.2227449. And I get this. So r is equal to 12.050, right? All right, so at this moment, I have this. And then what would be the diameter? Diameter would be, just times it by 2. And we get 24.1016. And what did they want from us? They wanted the diameter, and that right there would be 24. Okay, now for most of you, your head just exploded. So that's one way how to do this. And you're stuck with that way if they didn't give you multiple choice. But hey, they did give us multiple choice. So let's talk about another way how to do this. So if we did this a separate, different way, we know for a fact that we have 38 equals 30 over 360 pi r squared, right? So I'm going to zoom in and show you a different way how to do this. Does everyone agree that this is the diameter? All right, so if that's the diameter, what would have been the radius? The radius, you just divide by 2. That would be 3.5, 7, 12, and 24. All right, so we're trying these. If you plugged in 3.5 in for the r, so I'm going to put my calculator here and try these out. I want to see, does it pop out as 38? So here we go. So 30 divided by 360 times 3.14 times your r, which is 3.5 squared. I would get this number right here. Is that what I want? No, I want 38. So if I plug this 3.5 into here, I would get 3.2. I want 38, so that doesn't work. All right, what if I tried 7? If I plugged in 7, I would get 12.8, but I want 38, so that doesn't work either. How about if I plugged in 12? So 12 squared. I would get 37.68, which is really close to 38, isn't it? So that probably works. And how about if I plugged in 24? So 24 squared. I would get 150. So that's definitely not 38, so that doesn't work. So the only one that worked was this right here. Now, the dangerous part of that one is, you remember how 12 worked? So 12 worked. A lot of people might accidentally put in either 14, or they might think, oh, it was really this. So just be careful about that. So that was 2 different ways. One was actually algebraically, and the second way was just plug numbers in. So does 30 over 360 pi 3.5 squared work? No, it does not. And I tried 7 squared. That didn't work. So I'm just giving you an idea of what's happening. So 30 over 360 pi, I tried in 12 squared. That one worked. And then this last one, 30 over 360 pi 24 squared. That did not work. All right, so that's how we do this problem. For number 6, you pick whichever way you like the best, and have a great and awesome end of course exam.